The lesson today, we are actually going to look at more quadratic equations, solving mainly non-monic quadratic equation. So, by the end of the lesson, you will know how to solve non-monic quadratic equations using the null factor law. Now, yesterday I told you quadratic equations is y equals to ax squared plus bx plus c and a does not equal to 0. And then we need to solve when the parabola that's plotted on the quadratic equation that's plotted on the Cartesian plane, when y equals to 0, that is the x-axis intercepts. Now, you also know that a quadratic equation is a parabola. Let's have a look at when we plot it. Yesterday, I showed you the case where we have two x-intercepts. Alright? I think I've also shown you a case where there's only one x-intercept. Now, I got to tell you that in certain cases, there are actually no x-intercept at all. So here in this purple quadratic function, plotted as a parabola, you can see that the line does not touch the x-axis at all, nor does it cross the x-axis. In this case, there is no solution. This is the situation when we have to solve for x squared equals to minus 25. That does not happen because it is actually complex number. We don't actually, we are not involved with complex number at this stage. Now, I'm just recalling null factor law. If n multiplied by n equals to 0, n equals to 0 or m equals to 0, or m equals to n equals to 0. So yesterday we have used the null factor law to actually solve monic quadratic equations. Alright, let's do some examples now. So let's first look at the first one. 2x squared plus 10x plus 12. Do we solve it as a non-monic? Or, in fact, we can look at it this way. If I take out the highest common factor, I therefore have a monic quadratic equation. Alright, so therefore, factorizing the monic, we have x plus 2 and x plus 3 equals to 0. Using the null factor law, x plus 2 equals to 0 or x plus 3 equals to 0. Since we know that 2 cannot be equal to 0 anyway. So therefore, x equals to minus 2 or minus 3. What about this one? Can you pause the video for a while and attempt this question? The way I do it, I will take the 10 out. So here we have got x squared minus 4x minus 21 equals to 0. Again, we can then factorize the monic quadratic. It becomes x minus 7 and x plus 3 equals to 0. Since 10 cannot be equal to 0, x minus 7 equals to 0 or x plus 3 equals to 0. Therefore, x equals to 7 or minus 3. Note that I use the word 7 or minus 3 because there may be situation when you solve for the roots, you may actually solve for the x-intercept, you may not be able to accept the negative number. And notice that I use the word roots. I will elaborate roots a little bit the term roots a little bit more later. And just bear in mind, roots in this case means the x-intercept. What about this? Solving 3x squared plus 11x plus 6. You can see that this is actually a monic quadratic function. Non-monic quadratic function without any highest common denominator. So we need to use the way that I taught you to actually factorize this. We need two numbers which multiplies is 18 and adds up to 11. So just looking at that, I know that it would be, we need to split the term 11x into 9x plus 2x. So therefore, we can rewrite the quadratic as 3x squared plus 9x plus 2x plus 6 equals to 0. In this case, factorizing it, taking the 3x out, we've got x plus 3, plus taking the 2 out, x plus 3 equals to 0. Therefore, we have the common factor x plus 3, or factorizing this, 3x plus 2 times x plus 3 equals to 0. So therefore, using the null factor law, 3x plus 2 equals to 0, or x plus 3 equals to 0. X therefore equals to minus 2 over 3, or minus 3. Alright? A few more examples to show you. What about this? 6x squared plus 7x plus 2 equals to 0. Please pause the video for a while and attempt this question. We know that this is a non-monic quadratic equation. We need to find two numbers which multiplies and becomes 12 and adds up to 7. And we can see that this is 3 times 4. So therefore, rewriting it, 6x squared plus 3x plus 4x plus 2 equals to 0. Therefore, factorizing it by grouping 2x, 3x, 2x, oh, let's cross this out, let's redo it. It's actually taking out the 3x. This becomes 2x plus 1. And then plus taking the 2 out, this becomes 2x plus 1 as well, equals to 0. Therefore, we have 3x plus 2 and 2x plus 1 equals to 0. Again, using the null factor law. It says that 3x plus 2 equals to 0, or 2x plus 1 equals to 0. Therefore, x equals to minus 2 over 3, or minus half. Hope you get the same answer as I do. Got a few more examples to show you. How about something like this? 3x squared equals to 15x. This time, we need to rearrange it. Taking the 15x to the left hand side, 3x squared minus 15x equals to 0. Then we factorize it. Taking the 3 out, x minus 15 equals to 0. Knowing that 3 cannot be 0, x can be 0, or x minus 15 can be 0, x therefore could be 0 or 15. Alright, the next one, it's rearranging again. Try part B. Let's pause the video for a while. Use the same principle as part A and see if you could find the solution for this. Alright, I'm actually going to move the 46x minus 10 to the left hand side. We can see that there's a highest common factor, which is 2. Taking that out is 12x squared minus 23x plus 5 equals to 0. This time, what you need to do is find two numbers. The product should be 60 and it should add up to be minus 23x. And thinking deeply about this, it should be minus 20 and minus 3. So therefore, we can rewrite this. 12x squared minus 20x minus 3x plus 5 equals to 0. Factorizing, we can take out the 4x. Therefore, it becomes 3x minus 5. And here, taking out the minus 1. It becomes 3x minus 5 equals to 0. Therefore, let's rewrite this whole expression on the left hand side. It becomes 4x minus 1, 3x minus 5 equals to 0. Knowing that 2 cannot be 0, the null factor law will state that 4x minus 1 equals to 0, or 3x minus 5 equals to 0. Therefore, x equals to 1 over 4, or 5 over 3. It is alright if you leave it in fraction, unless we state it. So here, just a summary. quadratic equations of the form ax squared plus bx plus c equals to 0 when a does not equal to 0. So if you have a common factor, divide through by the common factor, or actually factor it by the common factor, which is what I showed you earlier. Alright. Now, if you divide through by the common factor, the proviso is that you cannot divide by the pronumeral, only the coefficient. Alright? Coefficient only. Now, to solve quadratic equation using the factorizing method, always write the equation in the form of ax squared plus bx plus c equals to 0, then factorize the quadratic. So this is actually the end of the lesson.